me.
Yes, miss.
Okay, so last time,
Yes, miss.
yes.
Yes, miss.
Anything, Abinido? Yes. Abinido. Okay, question?
Miss, ako rin try Grace, miss, pero makadungog ka, miss ba? Para
Okay.
makakuha ko sa stage.
So last time, we discussed about poison
By the way, miss,
distribution.
kanang nakoy concern erase din mo, miss, before sa miss. Kanang last time, miss ba, na wala ang internet sa lapo-lapo, miss. Wala ko kapas assignment, miss.
Lain na silang istorya. We'll go on to the
Naki-proof, miss, nag-screenshot ko sa sa that day ba, nga mapas ng tao sa kuan. Wa mo
Ano
internet.
man i-pass that day?
Di, nag-pass ko that day, miss. Kaso, ang kaso kay na-close na ko ba sa kuan. Kay wa mang internet yung sila plapo gud. Ambot sa nitabo ato.
Lagi unya unsa may imong concern unsa man?
Pwede pa ko makupas ato, miss.
Karon?
Habol lang tanako ba kay kuan.
If ever nga wala ka kapasa to during the time kay wa man ka mo internet, share hantod karon wa mo internet. So about after a certain time?
Kaso din ako
Or how
kapasa
about
to,
the
miss,
next
kay
day?
close naman. Na-close naman ang kuan.
O karon nya sa man nimo pagpass, close naman be. Pagtan unta ka. Sa ano pa plus, close naman to. Ay gina ma-open
Mo
ba?
lagi
Mo
po
di
na, miss, kay
problema.
that day lagi that day
Maulagi.
pagkahuman sa kuan na close
If
na.
ever, you listen first. Kapila na naman hitabo nga if ever, dili mo kas kay wala kay internet, you will pass it in another way. So kadaghan ang mo Gmail o kon. Kapila naman ko, were you listening when I explained ka? Inigtanaw na ko sa Gmail nga ni pass kay wala ka kuan. As long as it is within the time nga kuan, within the day, depende kung gipass ba dayon, I will consider. Kapila naman ko nag-explain ana, oy kapuyag balik-balik. Nya, kana ito pa man ang panahon sa mampor niya karon pa nimo ipas.
Kaysa, miss, I thought dili kong basag Gmail, miss.
Put lang ninyo kapila naman ko nag-explain ana eh. I do not know if you are listening. How many times have I told you, dili ko mo dawat. Pero, ang kato nag-email na ko, before I will erase it, I will delete it from the one, I will record everything. Kapila na ko nag-explain, but then, kato nagpa sa email, I will consider, pero it is not 100%, it is only 25%. Kapila naman na ako gibalik-balik ko eh. Kada ko anak ko ibalik-balik ko man na. Were you listening? Oh, mo na akong pangutana.
Yes,
ang
miss,
di na ko gusto
naminaw, miss, ang
mapasa na sa messenger. Pero ningon ko ninyo, by the time you will pass it, dili ko mo check ana dayon. Paghuwat mo kanus ako mo check anang email na ako kay dili ko magtagsa-tagsa check sa email. Pero everything is recorded. And how many times did I told you na when I look at the email, kung ni-coincide lang na siya sa date sa akong paghatag sa test, kung wa siya mapas kay walay internet, as long as it was in the same day, pagtanaw na ako na i-consider, but then that is only 25%, not 100%. Kapila na ako nagbalik ka balik, ano, if you were listening, di na ninyo problema nga mo question mo na ako yung ano. Kanto di sa katapusan, kasi magsikot suti. Biyon sa ba may
I tried na, miss. Ang kaso lang, miss, walay kwan nangutan ako sa kumong kauban, bef na bay email address nimo ba, wala man pud sila kabalo pud sa imong email address good. Mo Gmail, mo email ta kon mo to, wa man kabalo sa imong email address sad.
Man arason oy. If you want to know, daghan kay nag-email sa inyong klase nako. If you want to, actually you want to pass, there are many ways. If you want to pass, you can do it. If you do not want to pass, you still can do it. If you will have all the means nga you want to pass, hagbay ra na ima pass. Ay ginang imong amigo sa imong klase usara ka buok. Away email nako. Di ako mag-ipulan na nagbasa akong email kay mapuno ako notebook sa mga nag-email. Nga how come nga they were able to know it? Nga wala man sila mga ina kong email. Kaya gusto man sila mo pass. But if you do not want to pass, wala mahimo. Alangan mo kuan pa ko ni unsa na. So you should kuan ka mo mag-research unsa ninyo pag-pass if you really want to pass. It's not the reason. Daghan sa mag-email mao man gid akong kasaputan kay basta ang nag-email ako I will not check it during the time when I will be checking the papers. But then, before I will delete it, I am recording it para when I have already my class record, all is recorded, tanawon ko itong mga blanco una pa kung tanaw sa email. Tanawon sa nako unsa ang date, kay gi-record, naman ay date sa pag-email nyo, naa sa record sa LMS pagka-examine ana o pag-assignment. Kay there are some nga, ang assignment karon nag-email, after pila ka buwan, nya i-consider ko na ina.
Pwede mga
Dili
isang
na ko
email, miss.
ma-explain ana, oy. Again?
Mga ako sa mong email address ba? Kaya nga ko last time good katong paghumadyo sa klase good wa may nakahatag sa classmate good bisag isa.
Ano nga may email address yun naman na sa kuan tinangali. I think it is in the LMS. With the email, naka mo na mo email address nasa ko email address sa kuan. With the faculty. Posible man ikaw rin may nakareklamo na akong ay email ad.
Wala man, miss. Wala gid sa
email ad. Di na ta
wala gid diri
magsaba
sa kan, miss.
di na ta maglalis kay ngano no, di ta ka klase. Kapoy kaayo, it's not the time for maglalis ta. Di na
Ayos, miss.
kuan
Pero
na to
mga ilan ko sa mong
maglalis.
email address, miss ba?
I have no time to. I will have to start na with the lesson. You ask from your friends if you like. Daghan ninyo. May nakibaw. Anong daghan man nag-email? It's not the reason nga kuan. You are wasting my time. Okay, last time we were discussing about Poisson distribution formula and we had already an example for that. So if you will recall, our Poisson distribution formula is P of x. That will be equals to lambda raised to the power of x times the Euler's constant raised to the power of minus lambda all over x factorial. Now, I want you to know that this lambda in our Poisson distribution is just equivalent to our mean before. So your lambda is equivalent to the mean that we had before, and this is equivalent to the variance, wherein our variance is sigma squared. So again, we are relating it because in the binomial distribution, we have also that one wherein our mean is equivalent to the expected value. So using the formula last time with our example, we were able to have the solution of the problem using the Poisson distribution. Now we will have another application of which I am placing the solution so that it will be easy for you to follow so that we can go on to the, what is this, normal approximation. Okay, so we have the first one. What is the probability distribution for X, the number of fish that you will catch in 7 hours? So what is important is that you are going to identify the mean because that will be used. You will have the lambda. So, and then you will have X, which represents the number of samples that you will have in the problem. So in letter A, the mean number of fish is, ang mean number with the given one, with the given value you will have to catch it in 7 hours. So we have the number of fish in is that we, the mean number of fish that we are going to have will be 3 fish in 2 hours or 1.5 fish per hour. That is the mean. What is the probability distribution for X? The number of fish that you will catch in 7 hours. So we are given the mean number of fish is 3 fish in 2 hours. That is the given. So if we are going to solve for the mean, it is 3 divided by 2. That will be 1.5 fish per hour. The mean that this means that over 7 hours, the mean number of fish will be lambda is equals to 1.5 fish per hour. Or then times 7 hours, you will have it 10.5 fish. So in the equation, in the application of the equation, you will have your P of X is equal to lambda. With the formula, you have lambda raised to the power of X, that is Euler's constant raised to the power of minus lambda all over the X factorial. So that is our representation for the formula. Now, if we are going to substitute the value, our lambda or our mean is 10.5 10.5 fish raised to the power of raised to the power of x, and then you will have the Euler's constant raised to the power of lambda. Then we have the x factorial for the denominator. Now we will apply it to our letter B. To calculate the probabilities that you will catch 0.3 or 10 fish, perform the following calculation. So you have P of 0, so you are not catching any fish. Your lambda is equivalent to 10.5 as given in the problem. That is raised to the power of, we are solving for the probability of no fish that is being caught. So your 10.5 is raised to the power of 0. Then you have your Euler's constant, then raised to the power of minus lambda, which is 10.5, all over the probability of catching no fish, 0 factorial. You will have the answer. But if that one is with the answer right away, in your test, I do not want you to place the answer right away. You should give me the equivalent of your 10.5 raised to the power of x, that is 0, and then you give me the value of the Euler's constant that is raised to the power of minus 10.5. Be sure you will have the substitution of the values for that all over the 0 factorial. Before you will give me the answer nga 0.00, layo na kaayo, or it is equivalent to 0%. There is there is zero probability that there is no fish will be caught. Now then the next one is the probability of catching three fish. You will have a 10.5 substituting into the formula. The mean that you have is 10.5, or the lambda is equivalent to the mean raised to the power of x, which is we are solving for the probability of 3 fish. Now times the Euler's constant raised to the power of e, that is negative lambda all over 3 factorial. So again, you are going to substitute the values of the equivalent of 10.5 raised to the power of 3 and the Euler's constant raised to the power of 10, negative 10.5, and your 3 factorial. So with the substitution of the values before, you will have the answer of 0.0053. Or if you are going to transform your probability to percent, that will come out as 0.5%. Now the next one is the probability of getting 10 fish. We have 10.5 raised to the power of 10 times the Euler's constant minus the lambda 10.5 all over 10 factorial. So again, you will have to give me the substitution of the values before you will get or give me the answer of 0.1236 or 12%. So it shows that with the given data that the number of fish is 3 fish in 2 hours, giving you a mean of 1.5 fish per hour, which means that over 7 hours, because the given is 7 hours, so you'll catch in 7 hours. So the mean number of fish is 1.5. Your lambda is transformed to 1.5 fish per hour times the 7 hours. That is considered as the time for you to catch the fish. So you will arrive at a mean or lambda of 10.5 fish. Then after that, you will have the equation that will be applied to. So that is an example of the simple application of your Poisson distribution. All you have to do is just to identify your lambda, which is your mean of the problem. Now, the next one is the normal approximation to Poisson distribution. So if we had before normal approximation, kana what you consider in your your LMS, that is not the one that is Poisson distribution by means of normal approximation, that is different. We will have here normal approximation first to Poisson distribution. So which is just more or less the same as the normal approximation to binomial distribution. This time, it will be normal approximation to Poisson distribution. And to recall, in your normal approximation to binomial distribution, you were considering n times p to be greater than 5 or greater than 10, 5 or 10. So wherein your n times p is equivalent to your mean or expected value in your binomial. And then your n times p times q is your standard deviation. So that is for the binomial. And you have the continuity correction factor for the condition of the problem. Now this time, for the normal approximation to Poisson distribution, we are going to consider a very large value that is greater than 1,000. So greater than 1,000. So if we considered our value in normal approximation to binomial as 5 or greater than 10, this time we are going to consider greater than 1,000. So, and also remember that your sigma squared, which is the variation, is just equivalent to your lambda in your Poisson, equivalent to your mean. Now, we are going to apply this one by just considering that we will have here a very large value of the n. So for example, we are going to denote the number of kidney transplant per day. The mean number of kidney transplant performed per day in the United States is about, in a recent year, is about 45. So meaning to say that we will have a lambda of 45, that is the mean. And if we are going to consider the Poisson distribution, our x will be the probability of 45. Now your 45 is large enough, 45. It is large enough for us to make use of the Poisson normal approximation to Poisson distribution. But actually, that should have been greater than 1 to 1,000. So anyway, I will specify as to what method you are going to use when I give the test. So I will place first here the given. So the number of kidney transplants. Okay, so if we have the here, the number of kidney transplants per day in the US was about 45, we will be considering this one as our mu or the mean. So this is mu. This is, we have here the mean, which is equal to 45. So take note that this mean 45 is equivalent to lambda. This is equivalent to your lambda. So you have the symbol for lambda, that is 45. So we are going to use the normal approximation to Poisson distribution, considering it to be very large. So we will use normal approximation. Use normal approximation to Poisson distribution. Poisson distribution. So if you are going to use normal approximation to Poisson distribution, you will have to go back to the z-score, the same as our binomial. So you will have here your z-score. What is the formula of your z-score? What is the formula of your z-score? Okay, Abinido.
That is one is x minus mean over standard deviation.
Okay, over standard deviation. So therefore, if we are going to apply it to our Poisson, kailangan naman ato representation, we will have it as x minus, unsa tong mean sa Poisson distribution, it will be minus lambda. Dili na ni
Yes,
ibutang.
miss.
Ito to yung state mo, gyapon to because that is in words. But if you will have it as a representation of your Poisson, so it will be this time you will have it as x minus lambda. This will be auto representation should be a representation more or less the same as which is a representation of our the topic. Now at that will be x man or x minus ay miyo mali ako nabutang lambda ni. This is lambda. So this will be minus lambda because that is my x minus mean. This will be lambda. And then our denominator is standard deviation, right? Yung sa may itong standard deviation in terms of lambda. If our variance is sigma squared, square of the standard deviation, so what will be your representation of your standard deviation in terms of the lambda? Where your standard deviation is equivalent to, we will have here the square of lambda. square root of lambda. Okay, so this is x. So your G-score, you will have it as the mean minus the lambda, Poisson man, minus the lambda all over the square root of lambda, which is your standard deviation. So if we are going to consider our n as 0, 1 for large lambda, we will use continuity correction factor. So the probability that on a given day, exactly 50 kidney transplants will be performed. So what will be the probability that in a given day, number of kidney per, the question is that we are going to, ang question ani, what is the probability? What is the probability that on a given day, per day man siya, a given day, $50 kidney transplants will be performed. 50. Will be performed. Okay, that will be the question. What is the probability that on a given day, 50 kidney transplants will be performed? So, how will you represent your the problem for the probability? Ang inyong given is x is equals to 50 because it says here that 45. The mean number of kidney transplants per day in the United States is about 45. So, that is 45 mean number of kidney transplants per day in the US. Now, the problem is, what will be the probability that on a given day, exactly 50 kidney transplants will be performed? So, how will you represent your probability of the problem? That is exactly 50 kidneys will be performed. So, if you are going to transform this problem, if you will have to represent this one, your probability is that you will have your probability will be x will be equal to 50. That one, x will be equals to 50. But then if you're, because we are asked to give it in terms of the probability, the continuity correction factor, how will you, what will be the continuity correction factor for this problem equal to x? So what will be the continuity correction factor? It will be what? P what? Sama to yung continuity correction factor na that wherein x is equal to p. So what is your continuity correction factor? You write first the continuity correction factor. So to yung continuity correction factor, uy.
Ako, miss. Pwede ma-answer, miss, try?
Oh, yes.
Since P is x is equals to n, so I use P close open parenthesis, n minus 0.5 is less than x. And then less than n plus 0.5.
O, di makatujod ang inyong correction factor. So, if you will have to place this one, this will be n. This will be n plus this will be n minus. This will be n minus 0.5, right? Oh, n minus 0. This is in your correction factor 0.5. Then it will be less than or less than x, less than x, then less than
n
n plus n
0.5.
plus 0.5. Mo ninyong ibutang katong correction factor. This is the correction factor man. 0.5. So this is your correction factor, of which you are going to apply what is the value in your given problem. So linyera to na niya. Ganina si Abinido. Okay, we have Abinido. Then we have linyera. Okay. So mao na ibutang ninyo. So ang inyong problem is about what is the probability that on a given day 50 50 what is the probability that on a given day exactly kuwang ni word nga exactly 50 kidneys. Kung wala ng word exactly, di man mo ka-formulate exactly. So that is why we have the, what is this, equal. That is exactly. So ang problem ano, what is the probability that on a given day, exactly, So exactly 50 kidney transplants will be performed. So because of the word exactly, we were able to transform our one probability of the given problem as P, x is equal to 50. Okay, since we are asked to solve using the normal approximation to Poisson distribution or making use of the CCF, so ang atong tanawon, ang atong CCF factor for x is equals to n, I think, n. So this will be P n minus 0.5 less than x less than n plus 0.5. So after placing that one as the CCF, you will have to transform it by substituting the values. So this will be equal to P. So ito nang i-transform. So this will be equivalent, if you continue with this, this will be equal to P. Then you transform na, you make your substitution, that will be substitute una ni nato, then we will have, this will be n is 4, that is 450 minus 4.5, that becomes 49.5. That is 50 minus 0.5, so that is 49.5. That is less than x, less than 50.5. 50.5. So that is now applying na the continuity correction factor. So after that, you solve by substituting the value for your 49.5x less than 50.5. So what will be the next part of this? Ako lang kaning ko. Let's get this one. Okay, what will be the next part of this? This will be equal to, you will have it as, you will have the z z value of this. You will have to solve for the z score, wherein you will have your mean minus the lambda with your z score application all over the lambda. So therefore, in the first part, 49.5 less than x less than 50, your representation for this one is p, and you will have it as 49.5 this is minus 45, katong given ha, minus 45, then this will be all over ano to ba? Should have been quantity. This all. This is less than Ano ni? Reason. Less than x less than 15. Less than Okay. So you have seen next step, huh? If you will transform this probability of 49.5 less than x less than 50.5 from the continuity correction factor, this is an application of your z-score, wherein you will have the 49.5 minus 45 for the mean number of kidney transplants that is performed in the United States per day, that is 45. So you have 49.5 dx minus 45 all over square root of 45. So what will be the equivalent of that one? Just erase this one. You wait first kaya mag-erase pa ko. Ano mo erase eh? Okay, the what is the equivalent of 49.5 minus 45 all over square root of 45? What is the value of that one?
Ako, Miss. Try, Miss.
Kinsa man eh? Niera?
Lineara, Miss.
Okay, what is?
0.6708.
Okay, 0.67. We'll have 0.67. So we have it as 0.67. And then we will have this one as less than z. Kaya nang atong x minus lambda all over square root of lambda, that is our equivalent of our z. Less than our z-score. So that will be less than the value of 50.5 minus 45. Ito naman eh. Abinido. Doon na din nagabuktaw din eh. Abinido. Abinido.
Miss, that's con miss. That's 0.82.
Okay, 0.82. We have that is 0.82. That one. So, mauna na siyang equivalent sa anang before, ha? So, ang kanang x minus lambda all over square root of lambda, that is equivalent to our z-score. So, we have the value of subtracting and dividing it by the denominator, 0.67 less than z less than 0.82. So now we will have to get the value. We have 0.82, z of 0.82 minus z of 0.67. You will have to subtract it. What is the value of 0.82? To come out as this will be equal to P, and you will have it as Z. That's 0.82. G is 0.67. Okay, that's one. So your P is 0.67 less than Z less than 0.82. Your Z.82 is bigger, so we have it minus 0.67, but then it is not the 0.82 that you will subtract. You will get the value from the table. Pila yung value sa 0.82 ninyo sa table. So you look at the value of your B from the table. So that will be equal to pila yung value sa table sa 0.82. Pila yung value? 0.82 from your normal table. Duha raman ka estudyante diri eh.
Kuan Miss 0.7939.
0.7939. So we have here, the value for this one is 0.79. Okay. So ano. Diri mo ko diri na lang na yun. So wala ko type ano. Type 0.7939. So that is the value of your 1.3939. That is the value of your 0.82. Now what is the value of your 0.67? Nido. Abinido.
Yes, miss,
Yeah,
that's
yeah,
0.7486.
0.4876. That is 0.7486. Now this
Yes,
is
miss.
from the table. Yeah. This is from the normal table. So if you will subtract the two from this is equal to, you will get 0.043, 0.0453. That is the result of. So if we are going to determine as to what will be the probability that exactly 50 kidney transplants will be performed that day, it will be 0.0453, or if you will have this in percentage, this will be 4.53%. 4.53%. Now, we have the second question. What will be the probability that on a given day, at least 65 kidney transplants will be performed? So we'll have letter B, ha? Ang sa letter B, I will be asking for, sama niyo? Letter B. Letter B nga question. What will be the probability? Di na na-question what, ha? The probability on a given day, at least 65 kidney transplants will be performed. 65 kidney transplants will be performed. Now, what I am after is, how will you represent this one? What will be the probability that at least 65 kidney transplants will be performed? Ang ako importante ani ang pag-represent ninyo sa inyong probability that at least. So, how many pag-represent ninyo? That will be your P. The probability, how will you transform this problem? P will be what? What will be your X? Okay.
Greater than or equal to X, miss.
Kinsa man ni Nira?
Yes, miss.
Ya mao duha ra dayta kag estudyante ani ron yate. So this will be P will be X. Your X will be greater than or equal to greater than or equal to greater than or equal to 65, right? It will be 65.
Yes, miss.
So if that is the problem, that is the transformation of the problem. Unsa man yun? 65. If that is the transformation of the problem, what will be the equivalent of this one? Or how will you transform? Okay, kung greater than or equal to 65, how will you represent this power before the continuity correction factor? Now you can get the probability of this. It will be the, what is this? Moral kanang complement. So it will be, what will be the equivalent of this? Pwede man is greater than or equal to man. So greater than or equal to, daghan pa kay kagkuanan solbon. So that it will be shorter. Your representation will be, this will be equal to 1 minus P of X, P, and then you will have X. This will be equal to 1 minus P, then you will have it as X less than or equal to, less than or equal to 64. less than or equal to 64. Before you can use the correction factor, what you are going to apply for the correction factor is that you look at this one greater than or equal to, so may equivalent any correction factor. This will be equal to this is 1. Then minus P. Nakapalit with slicer, ha? Okay, you look at the transformation. So to get the complement of this x greater than or equal to 65, it can be written as 1p px is p. Okay, your px greater than or equal to 65, that can be written as is equal to p. Lain naman yun. Okay. So we have px greater than or equal to 65, which will represent the at least 65 that will be performed for 1 day, 65 kidney transplants. That will be 1 minus px less than or equal to 164. And then you will have it as 1 minus p of x less than or equal to 64.5. Try to look at the continuity correction factor. You try to look at the continuity correction factor for this condition, then it will be the same solution. You will go on to the z-score, then you will get the answer. You finish this one, ha? Una ni ang inyong condition nga i-transform ninyo sa CCF. So you will be, use after this one, you will have your CCF. because only 2 are listening. So mauna na ha. At least, what is the probability that at least 65 kidney transplants will be performed? So the representation is that P kay at least man that is will be greater than or equal. So that will be the probability of X greater than or equal to 65 will be equivalent to, para dili daghan ka inyong inyong probabilities 1 to 65 or greater than 65, you will have it as the complement nga 1, probability of 1 minus Px less than or equal to 64. And then, that less than or equal to 64, if you will have the, what is this, correction factor with Px greater than or equal to, that becomes 1 minus Px less than or equal to 64.5. So, using the continuity correction factor, you can get the probability that at least 65 kidney transplants will be performed in 1 day. Okay, just finish that one. I will dismiss the class. It's almost time. Do you understand, class? Kaya duha ra bay sige tubag-tubag. Do you understand? So you finish that one. I will ask for the answer of that one. But then on Thursday, I will give you an an assignment of this binomial and Poisson distribution with normal approximation, so that you can have your test next week, which will be already our semifinals. Okay, any more questions?
So
Wala
far,
kayo nang
Miss.
ninaw. Sige.
And
Okay,
so
so
far,
goodbye,
Miss.
class. Wala na may
Goodbye, Miss.
nanghina.
Thank
Duha na
you.
gyud kay estudyante. Okay, goodbye, class.
Bye, Miss. Thank you so much for today.
Bye. Bye. Only 2 students.